Please pause the video and read this word problem to yourself, and then we will get started. All right, so we're dealing with a three-dimensional shape, but we are going to be able to think of it in terms of 2 dimensions. We've got a lot of numbers here, and what is going to be most helpful is to have this hyperbola, or this section of a hyperbola, centered at the origin. Well, we've got that the base has a diameter of 400 feet. The diameter is, its narrowest point is 200 feet. And 360 feet, let's see, suppose cooling tower is a base diameter of 400 feet. The diameter at its narrowest point, 360 feet above the ground, is 200 feet. The diameter at the top of the tower is 300 feet. How tall is the tower? Well, out of all of this information, what I have underlined here in yellow is the information that will help us determine the center. The narrowest point is going to be, if we could think of it in terms of this, I've got, if you've ever seen Sharon Harris, you could really easily visualize this. So this is going to be our 200 feet. This is where our center needs to be. So we're going to have this as our center. It's 200 feet across, so this is going to be 100, and then on the other side of that is going to be negative 100. So we've got our hyperbola looking something like this. Okay, don't be alarmed. It's just some motorcycle racing in downtown Raleigh. All right, so the base diameter is 400 feet. So let's pretend this is the base of this. So the base diameter is 400 feet. That means this is at 200 feet out, and this is negative 200 feet out. Okay, and then we are told base diameter 400 feet, diameter at its narrowest point 360 feet above the ground is 200 feet. Oh, the diameter at the top of the tower is 300 feet. All right, so that's another piece of information. From here to here, clearly this is not drawn well to scale. That's going to be negative 150. All right, so let me find a brownish ground color. So here is actually this cooling tower sitting on the ground. Okay, we're told that that narrowest point is 360 feet above the ground. So we know that distance is 360 feet. So we could think of this as negative 360. Now we've got everything placed. The question is, how tall is the tower? So we want to know this total distance. We know from here to here is 360, but we'd like to know from here to there. You know what would be really nice? If we knew the y part of this ordered pair. We already know it's 150 in its xness. We'd like to know the y value of that, because that would be the height of this section we're missing. Well, to find that, we really just need to find the equation of this hyperbola. It opens left and right. Its center is at the origin. I know that that's going to be x squared over a squared minus y squared over b squared is equal to 1. All right? So I need to know A and I need to know B. I know that the distance from the center to one of the vertices is 100, which means this is x squared over, I'm just going to leave it as 100 squared because that's just a giant number. I'll deal with that later. I still need to know b squared. In other examples we've seen, we would know the focus and we would be able to calculate this, but we don't know that. So that's a bit of a bummer. Well, what's another thing that we might be able to do? If we knew another ordered pair on this hyperbola, we could plug in for x and y and solve for b. Well, my first thought would be, hey, how about negative 100, 0? That would be fun to plug in because zeros are always helpful, but not really here, because if we plug in a 0 for y, we lose this whole term, and the point of this is trying to find b. Well, another ordered pair we know is this point right here, 200, negative 360. We could use negative 200, negative 360. That's another point that we know, but I'm just going to use this version here. So here's my x, here's my y. I'm going to plug this in to find b. When I do, I get 200 squared divided by 100 squared minus negative 360 squared divided by b squared is equal to 1. I'll do a little simplification here. I went ahead and worked this out in the interest of time. I plugged in the ordered pair, I simplified that. That was a 4. Squaring negative 360, we get 129,600. Subtract 4 on both sides. Cross multiply. Divide by 3. And b squared is equal to 43,200. So I have x squared over 100 squared minus y squared over b squared, which is 43,200. Guess I might as well square out 100, but that's okay, is equal to 1. There's my equation of my hyperbola. Now remember, I would like to know this y distance, and it occurs at the y part of the ordered pair where x is 150. So now I will come back to this equation. I will let x be equal to 150, and I will solve this equation for y. When this equation is solved for y, very similar to how we solve for b over here, we get y is equal to 232.4. which means this ordered pair is 150, 232.4, and this height is 232.4, which when we add it to the 360 that we have from before, we get 232.4 plus 360 is equal to 592.4 feet, the height of the cooling tower.